Okay, now we're talking about finding the confidence level for a population mean when we know what the population standard deviation is. So we'll be using the normal distribution. Okay, so like I said, we have two cases, one where we know what the population standard deviation is, and one where we don't know what it is. If we do know what it is, we're going to be using the normal distribution. Okay, so your sample mean X bar, that is the best point estimate of the population mean. Because what we're trying to do is we have a population, and say I want to find the mean weight of everybody in that population. So that would give me mu, the population mean. But there's too many people, it would take too much time and too much money to find the mean weight of everybody in the population. So we're just going to take a sample. We'll find the mean from that sample. So what we're trying to do is we're trying to use this sample mean to estimate our population mean. Okay, our confidence level is 1 minus alpha, and your confidence level is going to go in the middle of your normal distribution. This is your margin of error. So you'll have a z-score times the population standard deviation divided by the square root of your sample size. And then here's your confidence interval. So you have a sample mean minus the margin of error less than the population mean less than the sample mean plus the margin of error. So it could look like 0.625 less than mu less than 0.782. You're not going to know a number for your population mean because we said, well, there was too many people or it took too much time or too much money to find that number. So we're going to try to estimate what our population mean would be between. So it would be between these two numbers in this case. Okay, so your confidence level will go in the middle of your normal distribution like it is here. On either side, you'll have alpha over 2. Your mean will be in the middle. The lower bound for your confidence interval will be here, and the upper bound for your confidence interval will be here. Okay, suppose scores on exams and statistics are normally distributed with an unknown population mean and a population standard deviation of 3 points. A random sample of 36 is taken and gives a sample mean of 68. Find a 90% confidence interval estimate for the population mean. Okay, so we are trying to find a confidence interval for the population mean, which means I need to use this format right here. So I have X bar minus the margin of error less than mu less than X bar plus the margin of error. They gave me what my sample mean was. That was 68. But they didn't tell me right off what the margin of error was. We have to calculate that number. So X bar is 68. The margin of error is a z-score times the population standard deviation divided by the square root of the sample size. They gave me the population standard deviation. That's just 3 points or just 3. They gave me the sample size. That was just 36. To find my z-score, they told me that it's a 90% confidence level. So I need to go to this important information right here. So if it's a 90% confidence level, then my critical value or my z-score is going to be 1.645. Okay, so 1.645 times 3 divided by the square root of 36. And this comes out to 0.8225. Okay, so these are the two things I need to plug back into my confidence interval. So I have 68 minus 0.8225 less than mu less than 68 plus 0.8225. Okay, that's going to give me 67.1775 less than mu less than 68.08225. Round to 3 decimal places, then that's going to be 67.178 less than mu less than 68.823. Sorry, that should be plus 0.8225. There we go. Okay, and there's our final answer right there. Okay, suppose scores on exams in statistics are normally distributed with an unknown population mean and a population standard deviation of 3 points. A random sample of 36 is taken and gives a sample mean score of 68. Find a, not a 90, but a 95% confidence interval estimate for the population mean exam score. So this is exactly the same as the previous problem, except for I'm not using a 90% confidence level. I'm using a 95% confidence level. So we would have the same situation. So X bar would be 68, and I need to find my margin of error, which is Z times sigma divided by the square root of N. Okay, they gave me sigma. That is just 3 points, or 3. They gave me the sample size, which is 36. I need to find my Z-score based on this confidence level, which back here, if I'm at a 95% confidence level, then my critical value is going to be 1.96. Okay, so we have 1.96 times 3 divided by the square root of 36, which that gives us 0.980. Okay, so I can plug that into my confidence interval. So X bar minus margin of error less than mu less than X bar plus the margin of error. So I've got 68 minus 0.980 less than mu less than 68 plus 0.980. Okay, so mu should be between 67.020 and 68.980. Okay, now let's compare these two. So for the first one, when I had a 90% confidence interval, actually level, we'll just say level, then our confidence interval was between 67.178 and 68.823. When it was at a 95% confidence level, we found it to be between 67.020 and 68.980. Okay. Notice when my confidence level goes from 90 to 95, my confidence interval becomes wider. Okay, so as your confidence level goes up, your confidence interval will become wider or more spread out. Okay, so this right here, increasing the confidence level increases the error bound, which that will make the confidence interval wider. Okay, so important part, increasing the confidence level will make the confidence interval wider. Decreasing the confidence level will make the confidence interval more narrow. Okay? All right, so say we're trying to calculate the sample size n. We've only got one formula here. That's it right there. So you're going to have a z-score squared, your population standard deviation squared, divided by your margin of error squared. Now make sure you always round up to the next higher integer if n is a decimal. Okay? All right, the population standard deviation for the age of Foothill College students is 15 years. Okay, so that just said sigma is 15. If you want to be 95% confident that the sample mean age is within, okay, this is a keyword, and the number behind it is going to be your margin of error, 2 years. Okay, so your margin of error is 2. 2 years of the true population mean age of Foothill College students. How many randomly selected Foothill College students must be surveyed? This part right here is really just saying find n, or your sample size. Okay, well n is equal to z squared times sigma squared divided by margin of error squared, which is the same thing as z times sigma over the margin of error, that whole thing squared. That'd be easier to put into your calculator. The only thing that I'm missing is z, but they gave me a 95% confidence level. Okay, so 95% confidence level, well, that's going to give me a critical value, or a z-score, of 1.96. Okay, so this is equal to 1.96 times 15 divided by 2, and this entire thing squared. Now this will come out to 216.09. Because this came out to a decimal, you got to go up to the next higher number. So this would be 217 for your final answer.